In this video, I want to address the question, which of these molecules is polar? So to start from the beginning, a bond can be polar if there's a difference in electronegativity between two bonded atoms. This then results in something called a dipole, a charge difference across that bond. However, if the molecule has symmetry and the dipoles point in opposite directions, they cancel out. And this means a molecule that has polar bonds can be non-polar overall. So let's look at these examples. We've got a molecule of fluorine. To get the electronegativity values, we use something called a Pauling table, and these values are called Pauling values. If we've got the same element bonded to itself, the electrons will be exactly in the middle of that bond because there's no electronegativity difference between the two bonded atoms. So this bond and this molecule are non-polar. If we look at our next example and we look at our electronegativity or Pauling table, we'll see that bromine has a higher value of electronegativity compared to carbon. That means the electrons in the bond are pulled closer towards the bromine compared to the carbon. And we can annotate a dipole which exists across this bond. So a dipole is a charge difference across the bond. And that dipole points towards the most electronegative atom, which in this case is the bromine. And we can do dipoles across all of these bonds. Another way we can illustrate that charge difference is by giving delta minus and delta plus values. So the more electronegative element gets the delta minus because those electrons are negative and they are pulled towards that element. The element that's less electronegative will get the delta positive because the electrons are being pulled away. And delta is a Greek symbol and it just means, in chemistry, it means a partial charge. So all of these bromine atoms get a partial negative charge because the bonding pair of electrons are being pulled towards them. And that's illustrated by the direction of the dipole as well. So if we look at this annotated molecule now, we can see that the dipoles are pointing in all opposite directions. And this molecule has symmetry. Because of that, the dipoles cancel out and the molecule overall is non-polar. So the bonds are polar, however, the dipoles cancel out and overall the molecule is non-polar. The same thing happens with carbon dioxide. So oxygen is more electronegative than carbon. The dipoles point towards both oxygens. The oxygens gain the delta negative partial charge because the bonding electrons are pulled towards them and pulled away from the carbon, which gains the delta positive. See, these dipoles are pointing in opposite directions. They cancel out and this molecule is non-polar. So I'm sure you can work out the correct answer is this one now. Fluorine is the most electronegative element. So it's a lot more electronegative than phosphorus. That means the dipoles and the pair of bonding electrons are pulled towards the fluorine. The phosphorus will gain the partial positive charge and each fluorine gains a partial negative charge. Now if we look at the direction of these dipoles, they are pointing in an overall direction. They don't cancel out. They're all pointing sort of in a downwards direction. There's no dipole that's pointing upwards, which means the dipoles do not cancel out. This means that the overall molecule is polar.